Welcome to Introduction to Logarithm. In this lesson, I'll be showing you the fundamentals of logarithm, what you need to know before you get started with logarithm. So let me show you that. What's a logarithm? The logarithm of a number is a mathematical operation which determines how many times a certain number, called the base, is multiplied by itself to produce another number. For an instance, we have the number log 100 in base 10. So 100 is the number we're looking for its log, and this 10 is called the base. So we're saying right here that how many times will this base multiply itself to produce this number? How many times will 10 multiply itself to produce 100? And that will be 2 times, because we have 10 multiplied by 10 to give us 100. So our log 100 in base 10 will be 2. Okay, let's consider another example there. We're looking for log 1000 in base 10. So how many times will this base multiply itself to produce 1000? How many times will 10 multiply itself to produce 1000? And that will only be 3 times, because we have 10 multiplied by 10 multiplied by 10 to give us 1000. So that means our log 1000 in base 10 will be 3. Okay, who actually invented logarithm? Logarithm was invented by a Scottish scientist called John Napier in the 17th century. Okay, we're looking at the parts of logarithm, and we're considering the parts being divided into two. The parts is divided into characteristic and mantissa. So if you're given a number, like looking for the log of this number 13580, it will give the value 4.1329. So this first number here, 4, before the decimal, is the whole number part, and that whole number part is called the characteristic, or is the integer part, the whole number part. Okay, so then after the decimal, 0.1329, that is the mantissa side. So that's where we have the decimal fraction. The next thing now is to observe the characteristic of logarithm. So the characteristic of logarithm is the whole number part of a logarithm. It can be positive or negative. Okay, let's see example on that. So if you look at this number right here, they are logarithms. The starting number here is 2 point. This is positive integer or positive whole number, and this is 0 point, is positive. You see 5 points, so 5 is positive. Then let's see example on negative characteristic. Okay, you can see that a line is on top of this 1, and a line is on top of the 2, another line is on top of the 3. This line is called bar. Okay, so whenever you see a bar on top of a number, or you solve the characteristic and you have bar, so such characteristic is negative. So a positive one doesn't have any bar on top. Okay, let me now show you the things you need to note when determining the characteristic of logarithm. So the first one will be, if a given number is greater than 1, then we can say positive characteristic will be obtained. Okay, what do I mean by that? So we can apply the formula characteristic equals to number of digits before decimal minus 1. Let's see an example on that. you have the number 459.3. You are asked to look for the log of this number. So the first thing you do is to ask yourself, is this number greater than 1 or less than 1? If you look at the number 459.3 is greater than 1. That means you will obtain a positive characteristic. So if you follow this formula, number of digits before decimal. So if we count it, we have 1, 2, 3 before this decimal. So all you need to do is to just say 3 minus 1 and you have 2 as your characteristic. So let's see another example. And this example now we have 45.93. So in this one now, all we need to do, check the number if the number is greater than 1 or less than 1. Well, 45.93 is greater than 1. That means if we apply the formula, number of digits before decimal, 1, 2 before this decimal. So we only have 2 digits before decimal. We just say 2 minus 1 and we have our characteristic to be 1. So let's look at another example. Okay, this one now we have 4.593. In this particular one, ask yourself the question, is this number greater than 1 or less than 1? So 4 is greater than 1. So all you need to do there is to count the number of digits before the decimal. So if you count it, we only have 1 digit before this decimal. So we say 1 minus 1 and we get our characteristic there to be 0. The second thing to note when determining the characteristic of logarithm, if a given number is less than 1, negative characteristic will be obtained. So in this case, we're going to make use of the reference position. So reference position can be obtained immediately after the first non-zero digit. So let's see an example on that. You're given a number to look for the logarithm, as we have here 0.2145. You have to look for the logarithm. So the first question you ask yourself, is this number less than 1 or greater than 1? If you look at it, because it's starting with 0, that means it is less than 1. If the number is less than 1, so we're going to make use of the reference position. So let's try to do that. So to get our reference position right now, we need to locate the first non-zero digit. If you look at after this 0 now, the first non-zero digit that we encounter is this 2. So our reference position will be immediately after it. That means reference position will be in between 2 and 1. So reference position is around here. Okay, in such scenario, all you just need to do is to count from here. So you're going to count from this decimal point to that reference position to know your characteristic. That is 1. Since that is 1, that means we will have a characteristic of bar 1. Let me show you another example. In this question, we have 0.04517. We asked to find the log of this number. So the very first thing you ask yourself, is this number greater than 1 or less than 1? Well, you can see yourself 0.0. That means the number is less than 1. So in this scenario, make use of the reference position. So reference position will be located immediately after your first non-zero digit. So let's try to see. This is the first digit, this is the second digit. Then but this one is starting with 0, this one is starting with 0. So that means our reference position cannot be here, our reference position cannot be here. So our reference position will truly be where we have the first non-zero digit. So and this 4 is the first non-zero digit. So our reference position will be immediately after it. That means in between 4 and 5. So our reference position is around here. So all we need to do is to count from our decimal point to that reference position. So counting from our decimal point, we'll have like this: 1 and then 2, since we have our reference position here. So that means our characteristic will now be bar 2, since we counted 2. Okay, let me also show you another one. You're given 0.001695 to determine the logarithm. So in this scenario, ask yourself the question: is this number greater than 1 or less than 1? If you look at this number 0.00, that's an indication that the number is less than 1. Okay, in such scenario, so all you need to do is to make use of your reference position. How do you locate your reference position? The first non-zero digit. So where's the first non-zero digit here? The first non-zero digit is this 1. So that means our reference position will be immediately after the 1, in between 1 and 6. Okay, so the next thing to do is to count from your decimal point. So let's do that. So counting now, we'll take it this way: 1, 2, and 3 to where our reference position is. So that definitely means that we will have the characteristic of bar 3. Okay, now is the time to show you the very first example. In this example, we asked to use a logarithm table to find the logarithm of the following numbers: 546 and 65.47. So we're going to start with the first number, which is 546. So what we need to do now is to determine our characteristic first. So ask yourself the question: is this number greater than 1 or less than 1? Well, 546 is greater than 1. That means we make use of the formula that says the number of digits that appear before the decimal minus 1. So the number of digits that we have in this particular number is 3, because decimal will be here, that's immediately after the 6. So if we count from here, 1, 2, 3, so that will be 3 minus 1, and we have our characteristic to be 2. So the next thing is for us to go into our log table and look for the log of 54 under 6. Okay, we are at the logarithm now. So first and foremost, if you look at the starting number here in this logarithm table is 10, and the ending number is 99. Then from this 0 to 9 is the under, and then from this 1 to 9, that's called the difference. So all these ones are difference. So let's look for the logarithm of 54 under 6. So we need to go to the number 54. So this is 54 right here. So then we need to move to under 6. So you can trace it up to see whether you are under 6. This is 6 right here. So if you trace it down, the meeting point of 54 and 6, that is 7372. Okay, so from our log table we obtained that our log 54 under 6 will give us 7372. So let's look at the example 2, which is 65.47. So in this scenario now, going to our log table, we're going to look for 65 under 4 different 7. So let's do that. But before we do that, we need to determine the characteristic. So in this scenario characteristic, count the number of digits before the decimal, 1, 2, and then subtract 1 from it. 2 minus 1, that will give 1. So our characteristic there is 1. So let's go into our log table to determine our logarithm of 65 under 4 difference 7. Okay, we are the logarithm now. We are determining the log of 65 under 4. So let's go to 65. This is 65 right here. So let's go under 4. Under 4, trace it to the up and make sure you are under the meeting point of 65 and 4. That is 8, 1, 5, 6. And then difference 7. So trace it to 7 and make sure you're under. You can see difference 7 here. So difference 7 is 5. So if you trace it to the 65, you can see right here is 5. Difference 7 is 5. So all we need to do, the value you get here, 65 under 4, you're going to add the difference to it. So we have 8156 plus that 5 that we got for our difference, and the value will now be 8161. Okay, coming back, we have our log 65.47 to be 8161 from our log. So that means the log of this one is 1.8161. Let me show you the example 2. In this example, we are asked to find the logarithm of the following numbers from the A to F. So we are going to start with the first one, which is 8.923. So in order for us to determine the logarithm of this one, we're going to make use of our calculator right here. In our example 1, I show you how to make use of the 4-figure table to do it. But in this very example, we are making use of our calculator. So first and foremost, look at the number and ask yourself this simple question: is this number less than 1 or greater than 1? Since we have 8.923, it means this number is greater than 1. So in such scenario, that means we can use our calculator to determine the logarithm directly. So let's try to do that. Put on your calculator. Okay, but before we do that, I would like to explain something to you here. If your calculator is built with a prefix style, that means you will press your log first before the number. But if your calculator is built using the postfix style, you have to press the number first before you press the log. So you just need to check your calculator and see what is built of. So like in this scenario now, this calculator I'm using here is built on prefix style. So that means you press your log first and then press your number 8.923, and then you press equals to or enter, and then you can see right there we have 0.9505. So what I want to tell you is this 0 is the characteristic. Then from this point, the 4 digits after the decimal is a mantissa. So that means we have to approximate to this last 4 digits. So mantissa is always 4 digits: 1, 2, 3, 4. So that means if you need to do any approximation to this 5, you approximate to this last digit of the mantissa. So my note is this: any number from 0 to 4, if you approximate it, is going to give you 0. I mean, if you approximate 0, 1, 2, 3, or 4, it's going to give 0. But if you approximate any number from 5 to 9, 5, 6, 7, 8, 9, is going to give you 1. Okay, in this scenario now, if you look at the number after the 5 where we're supposed to stop our 4 figure, so this number is 1, and the approximation of 1 gives 0. That means if you add 0 plus this 5, we'll still have 5 there. So our logarithm there will be 0.9505. Okay, so let's look at the second one, which is the B. We're looking for the log of 54.8. So in this scenario too, if you feel like making use of your 4-figure table, all you need to do is to check your log 54 under 8. But if you're using your calculator like me, so just look at the number and ask yourself the question, is this number greater than 1 or less than 1? If it is greater than 1, you can say 54.8 is greater than 1, so you can use your calculator directly to determine the log. So just press log 54.8 and press equals to or enter. That will give 1.738. we are supposed to stop at this 7 right here. So I told you the 1 is the characteristic, and after the decimal we only have the mantissa to be 4 digits. So that means we're going to stop at this 7. So we need to approximate the numbers after the 7, sorry. So 8 is the number after 7. So if we approximate 8, the approximation of 8 will give 1. So we add the 1 to the 7, and we now have 1.7388. Okay, 1.7388. So let's look at the C. In this one now, we're given 6780. So to determine the logarithm, so let's use our calculator to do that. If you look at this number is greater than 1. So we can use our calculator to do it directly. Okay, just press log. Then point of note, I told you from the beginning that you have some calculator whereby you need to press the number first before the log, and you have some calculator whereby you need to press log before the number. So it's just a point of reminder. So in this case, log 6780, we'll press equals to or enter. So we have 3.8312. So we are stopping at this 2. So if we need to do any approximation to this 2, because this 2 is where we have our 4 mantissa stopping. So this 3 here is the characteristic. Then from 0.8312. So if we approximate 9 to this 2, we have this place to be 3. So if we approximate 3 will give us 0. 0 plus this 2. So we now have a final answer there to be 3.8312. Okay, so let's look at the next one, which is the D. The D is 83200. So we are to determine the log of this. So check out the number and see whether it's greater than 1 or less than 1. This number is greater than 1, so we can use our calculator to determine the logarithm. Okay, just press log 83200. Press equals or enter. That will give us 4.9201. So we are stopping at this 1 because the mantissa side needs to be 4 digits. So the 4 there is a characteristic. So if you need to do any approximation to the 1, if you see the number after the 1 is 2, the approximation of 2 is 0. So that means 0 plus this 1 will still have the same 1 there. So our final answer there is 4.9201. Okay, let's look at the question E. We're given 4.002. So ask yourself the question, Is this number greater than 1 or less than 1? Well, this number is greater than 1, so we can use our calculator to determine that directly. Okay, so we press the log 4.002. I press equals to or enter. So and we have 0.602. So this last 2, that's the last digit of the mantissa. So our mantissa starts after the decimal. So if you count 1, 2, 3, 4, so we're supposed to stop here. So all we need to do is to approximate to this last digit of the mantissa. So if we approximate to this last digit of the mantissa, these 2 will become 3. If you remember, the approximation of 7 will give 1. So if you approximate from here to this one becomes 8, and you approximate 8 to this 2 will become 3. So and we now have the final answer to be 0.6023. Okay, let's look at the next one, which is the f. In this scenario, we are asked to determine the logarithm of 7045000. So let's use our calculator to solve this. If you look at the number is greater than 1. So we're using our calculator to do that directly. So log 7045000. Now press equals to or enter, and that will give us 6.8478. So we are supposed to stop around this 8. So look at the number after it and see if you can approximate the number. So since the approximation of this 8 after this one, this 4 digit of the mantissa, the last 4 digit of the mantissa, we can approximate it. So if approximation of this 8 we give 1, we add the 1 to this 8, and this 8 becomes 9. So mantissa is allowed to be 4 digits. So the 6 here is the characteristic. So our final answer should be 6.8479. Okay. Now let's look at example 3 together. In this example, we are asked to determine the logarithm of the following numbers. We have from A, we're starting from there, we have 0.234. So to determine the log of this number, the first thing we need to do is to ask ourselves the question, is this number less than 1 or greater than 1? If you look at this very number, it's starting with 0, that means the number is less than 1. In such scenario, we cannot use our calculator to determine this value directly. So what we need to do first is to determine our characteristic, and then after that we make use of a workaround using our calculator. But if you're making use of a 4-figure table, after determining the characteristic, then you just go to your 4-figure table, the logarithm side, check 23 under 4. But if you're using your calculator like me, let me show you that. Okay, first and foremost, the first thing we need to do is to determine our characteristic. So our characteristic can be determined using our reference position. So our reference position will be after these 2, that's in between 2 and 3. If you remember, we've talked about this in our lesson. So all you need to do, if reference position is here, just count from the decimal point to that reference position, and then the counting that we have there is only one count. Since it's one count, that means we'll have the characteristic to be bar 1. So the next thing now is to use our calculator to determine the log of 234. So if you're using your 4-figure table, just go to your log table and check 23 under 4. So let's use our calculator to do that. So we're making use of a workaround here. So we're pressing log 23 4. That's 234. Then enter or equals to. So you can see the value that is given right here. So this is what I want to tell you here. Since we are making use of a workaround here, we are going to neglect the characteristic. We're not going to make use of this characteristic. So the only thing we want to make use of is the 4 digits that appear after the decimal. 4 digits that appear after the decimal, and that is 3, 6, 9, 2. So if we need to do any approximation to this last digit, which is the last 4 digits, so we approximate there. So if you approximate to this one becomes 2, and we approximate 2 is going to give us 0. 0 plus 2 is still 2. That means the only 4 digits, which is the mantissa that we need, is 3, 6, 9, 2. And then the log of 0.234 will now be bar 1.3692. Okay, so let me show you something. When I said if you determine this directly using your log to give a wrong answer, so let's see that. Use your calculator and press log 0.234 and press enter or equals to. If you see right here that the answer is very wrong, so let's press close that. Okay, then let's look at the example B. We are given 0.0125. So ask yourself the question, is this number less than 1 or greater than 1? Since it's starting with 0, you definitely know that this number is less than 1. You have 0 points. Okay, in this scenario, determine your characteristic first, and the characteristic here will be determined using our reference position. Our reference position will be the first non-zero digit that we encounter in this number, and the first non-zero is this 1. So all you need to do, that reference position will be after the 1, in between 1 and 2, so reference position will be here. Then all we need to do is to count from this decimal point to that reference position, and we have 1, 2. That means there we'll have, since we have 2 there, all we need to know, our characteristic will be bar 2. And the next thing for us to do is to now check around this 1, 2, 5. So if you are using your 4-figure table, go to your logarithm table and check 12 under 5. But if you are using your calculator like me, we are making use of a workaround. So take your calculator and just press log 125. Press equals or enter. That's going to give this value. So we are not going to make use of the characteristic. The only thing we need here is the mantissa, and that is the 4 digits that appear after the decimal, and those 4 digits is 0, 9, 6, 9. So you can check around. 9 is the last digit there, so check the number after it and see if there is any approximation that you can do. So if you approximate to 1, 1 is going to give 0. That means we still have 9 here. So the 4 digits of the mantissa that we need here is 0, 9, 6, 9. So that means for the log of 0.0125 will be bar 2.09069. Sorry. So bar 2.0969. So let's look at the C example. We are given 0.00258 to determine the log of this. So ask yourself the question, is this number greater than 1 or less than 1? Since it's starting with 0 points, you definitely know that this particular number is less than 1. In such scenario, you determine your characteristic first. So to determine your characteristic, you use the reference position. Reference position will be located immediately after the first non-zero. In this number, our first non-zero is this 2. So the first non-zero digit, so let's try to count from here. 1, 2, 3. So this is the place where we have our reference position. So that means since we got 3 there, that means our characteristic will be bar 3. So having gotten the characteristic, then if you are using your 4-figure table, check 25 under 8. Or if you're using your calculator, so let's do it with the calculator using a workaround. Okay, with our calculator, press log 258 and press equals to or enter. So the only thing we need here is the mantissa side, which is the 4 digit after the decimal. So we don't need this characteristic, which is the 2. We only need 4, 1, 1, 6. So we're stopping at 6. So if you need to do any approximation to the 6, so you can do that. So if you look at this last number here, if you approximate the 9 to the 2, and the 9 to this one will become 2, and if you approximate 2 is going to give 0, while the 0 plus 6 is still 6. That means the 4 digits of the mantissa that we have here is 4, 1, 1, 6. So that means our log for 0.00258 will be bar 3.4116. So let's look at the next example, which is the D. We're looking at 0.000451. Okay, in this scenario, ask yourself the question again. This number, is it less than 1 or greater than 1? If you look at it, it's starting with 0 point. It means it is less than 1. So in such scenario, determine your characteristic first. And to determine your characteristic, you need to know where your reference position will be. So your reference position will be immediately after the first non-zero. And the first non-zero in this number, the first non-zero digit in this number is 4. So if you can see right here is 4. So all we need to do, that means reference position will be immediately after the 4, in between 4 and 5. Okay, so all you will do now is to count from this decimal point to that reference position, and we have something like this: 1, 2, 3, and 4 to the reference position. So that means our characteristic will be bar 4. So the next thing to do now is to check the log of 451. So if you are using your 4-figure table, check 45 under 1. If you are using your calculator, so let's make use of the workaround. Okay, press log 451 and press equals or enter. So the only thing we need here is a mantissa, and the mantissa is the digit that appear, 4 digits that appear after this decimal point. So we don't need the characteristic. So the only 4 digits that we need is 6, 5, 4. We are stopping at this one. So look at the number after the 1 and see if we can approximate that number. So if you look at 7, the approximation of 7 will give 2. The approximation of 7 will give 1. So all you need to do, add the 1 to this 1, and that will give 2 right here. So that means the mantissa side that we need will be 6, 5, 4, 2. So the log of this number 0.000451 will be bar 4.6542. Point of note here again: if you determine to solve the log of a number that is less than 1 using your calculator directly, you're going to get a wrong answer. I show you an example on that when we're solving the question A. So if you look at all the question right here from A to D, they are all less than 1. So if you decide to use your calculator to work around the logarithm, it's going to give a wrong answer. So we make use of a workaround, determining the characteristic first, and then using your log to solve the number that is inside that number, and then pick out the mantissa.